Hello guys, so in this video we are going to do continuity. So what do we mean by continuity? If I say something is continuous, what do you understand? Continuous means it is moving without stopping. Yes, something which is not interrupted is continuous. So here we will be studying about continuity of a function. Okay, and to understand this you need to know limits. Okay, because always we'll be writing limit extending to some value, so you need to know limits. So I would request you to check the previous video on limits which I made and then come to this video. Okay, so let's start. So the topic is continuity of a function. The continuity of a function means what? As I said, continuity means something which is not interrupted or not broken in between. That is called continuity. Okay, and if we say continuity of a function, that means when we draw a graph for a function, okay, some function like this, now you can see this function is moving smoothly, right? It is going up, we cannot see any break anywhere, then it is coming down. Okay, so it is moving in this way. So you can say this function is continuous because it's from -1 to 8. You can see this function is not breaking anywhere. Okay, you need to focus on the interval also, from where to where we are talking about. Okay, so if I say from -1 to 8, we see that the function is not breaking anywhere. Yes, so we can say this is a continuous function. Continuous function is also denoted, also written as CTS, continuous. Okay, now let's see one more example. Now see this function. Okay, now if I ask you from 0 to 4, in this interval, is your function continuous? So you see a graph from 0 till 4. Till 4 you see. Till here. Is there any break in the graph? No. So you will say that in the interval 0 to 4, the function is continuous. Right. But now if I tell you that from interval 0 to suppose 6, 0 to 6. Now tell me whether the function is continuous or not. Now you can see here there is no value. And let's assume that this is the middle of that. That is the middle. This value is 5. Suppose this is 5. So you can see at 5 the value is not there with us. Okay. And the graph breaks at this place. So then you will say the function is not continuous in the interval 0 to 6, because you can see at 5 there is no value in the graph, right? So then you will say it is not continuous. Here, or in as a whole, if you want to say directly, you can say this function is not continuous. Okay, it will be better if you tell in which interval it is discontinuous. Okay, so here you can say from 4 to 6 also, the interval 4 to 6, the function is not continuous. Here, let's see a graph. Okay, now let's see this. Okay, now see, let's focus on these places. Here, 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 and here. Let's focus. Now let's see, in this place, at this interval, if I say my interval is, this point is 1. Okay, so if I ask you whether the function in the interval 1 to 2 is continuous or not, you see from 1, function is starting and going like this till here. Okay, so this is continuous, you can say. Now if I ask you about the function, about this function from 2.5 to 4, what do you think about this function, whether it is continuous or not? Okay, so whether it is continuous or not, how will you decide? See, from here the function is like this. Okay, so at x equals to 3, which is this value, you see there is a point here which is 4.1, this one 4.1, right? At x equals to 3, 4.1, but below you see at x equals to 3, I don't have a value. Okay, I have written this point at x equals to 3, it will be minus 2 according to this here, minus 2, but you can see this is a open circle, so that means there is no value. So at this point for x equals to 3, there is no value here. Okay, so function becomes discontinuous here at the point 3. At 3 it becomes discontinuous. You can see there's a break. Okay, now you can see at this point x is 5 and y is 2.2. Y is plotted here, x is plotted here. So you can see the function doesn't break, so I can say this is continuous. Here also you can say continuous. Okay, so the idea is clear of about continuity. Now I will tell you one thing. If you are asked to check whether the function is continuous at x equals to 3 or not, mathematically how you will check. Okay, so what you will do, first you will move towards 3 from left hand side. This is my left hand side. Okay, so you will move towards 3 from the left hand side, and moving towards 3 from left hand side means you take values like this: 2.9, 2.999, 2.99999. So you are moving closer and closer to 3, right? Approximately 3 you are moving, right? So when you come closer and closer to 3, you check the value of your x. Okay, this is your x, this is your x, you check your fx at these places. Okay, now if you check your fx at these places, then you check your fx at 3. Clear? Then you come from right hand side towards 3. Okay, right hand side means 3.01, 3.0001, 3.00000001. So you come towards 3 from the right hand side. See, now you can take one more value, 3.1. Okay, so 3.1 is here, and 3.01 will be here, more closer and closer. Okay, so you come from right hand side and you check your fx value at these places. Okay, these are your x. You find your fx, and if you see that all these fx are equal approximately, then you will say the function is continuous. But here you can see at 3 your function value is 4.1. Okay, we plot y also, and y is same as fx. Clear? So at x equals to 3 your fx is 4.1. Okay, but here you see as you move to 3.1, 3.1 is here, so you will see the value is down here. That means almost minus 1.9, right? And here you see at right hand side, if you take this was 3.1 here. Okay, x is 3.1, which is this one. See, and what is your value? The graph is here, so that is value. I'm just writing approximately 1.9. Suppose you take 2.9, which is 2.9 is here. Can you see? So corresponding to this, you will see your function value is what? 4. So do you think? And you're at 3. At 3, what is the value? 4.1. So 4.1 and 4 approximately I can write. They are same, right? But can you write 1 minus 1.9 is equals to 4? Can you write? You cannot write. So here you will say the function is not continuous. Clear? So how do we define our continuity? If you are asked to check the continuity at a point, You come from the left hand side towards the point, you come from right hand side towards the point. And if you see both the values, left hand limit, that means coming from left hand side, the right hand limit, that is coming from the right hand side, are equal, and they are equal to the value of the function at that point. Okay, here I'm talking about, so that is point. Okay, so if this is satisfied, then you will say function is continuous. Clear? Okay. And now let's see the definition. A function fx is said to be continuous at a given point A if and only if. If and only if what happens? Left hand limit is equals to the value of the function at the given point, that is A here, see, and it is equals to right hand limit, or left hand limit, this I've expanded here, left hand limit equals to f of a equals to right hand limit. Mathematically we represent like this. Okay, limit x tending to a minus, so suppose a is like this, so a minus will be smaller than a, so from left hand side. Okay, this here will be a minus, and that should be equals to the value of the function at a, that should be equals to value of the function at a plus, where a plus means little greater than a. If this happens, then you will say our function is continuous. Okay, I think it's clear. So this continuity topic has only this much. Okay, just few rules are there on that continuity, just like limits. So if fx and gx are two real functions which are continuous at a real number c, okay, at c these functions are continuous. Okay, so at c continuous means limit x tending to c minus f of x is equals to f of c is equals to limit x tending to c plus f of x. Okay, so this is, if this is satisfied, then you will say function fx is continuous at point c. Clear? So here they are saying already there are two continuous functions, so if you are adding them, they will also be continuous at x equals to c. Okay, if fx is continuous at c and gx is also continuous at c, their sum will also be continuous at c. Similarly, their difference also will be continuous at x equals to c. Clear? Their product also will be continuous at c, and their division will also be continuous at c, provided the denominator should not be 0, otherwise it will be not defined. Clear? So this is what we have in continuity. Let's see an example on continuity. Suppose I have a function fx is equals to x plus 1 when x not equals to 0 and 1 when x equals to 0. Okay, so we need to check the continuity. We need to check the continuity at x equals to 0. Okay, if this is not given, then also you should know that the function takes two values where at 0. Okay, the question shows us that the function becomes two different functions at x equals to 0. It splits itself. Okay, at x not equals to 0 it will become this, at x equals to 0 it becomes 1. Okay, so if it becomes two different functions at a particular point, then you should be concerned about checking its continuity at that point. So here you can see at not equals to 0 it is this, and at 0 it is 1. That means when x equals to 0 the value is 1. but when x is not equal to, that means in this way, in this direction, okay, when x is equals to, when x is equals to 0, your function becomes 1, right? And if it is not 0 on this side it will be x plus 1 and x plus 1 in this side also. This means, this is what we understand by this, when x not equals to 0. When x is not equals to 0, it will take all other values on both sides, right? So if something like this is happening, function is taking two different, function is splitting itself, it's becoming two different functions at a point, then you will check the continuity at that place, okay? So now first I need to check function's value at a. So what is a? 0. So if when x is equals to 0, what is the function? Function is 1. So this is my first part, okay? Now I need to check left hand limit. How do we check left hand limit? Limit x tending to 0 minus f of x. Now by looking at this, what do you understand? 0 minus. So let's take it like this. Let x is equals to 0 minus h. 0 minus h, why I am taking? H is very small. Okay, where h is very small. Now where it lies on the line, let's see. If this is 0, 0 minus h, 0 minus h will be lesser than 0, 0 minus h will, let's make it 0.0001, right? And that will be equals to minus 0.0001. So it will be somewhere here, very near to it, somewhere here, right? So that is my point. So that is what I am saying. I am coming from this side, left hand side. That's why I took x equals to 0 minus h. Okay, to denote that I am coming from left hand side. Okay, so now you can say as x goes to 0, h is also going to 0. If I write 0 here, because x value goes to 0, right? So as x goes to 0, our h will also go to 0. Clear? So why I am doing this? I am transforming my variable here. This is how you have to do. So I write h equals to 0 now. Okay, now I'm making everything in terms of h. The function f of, what is our x? Here it is x, so x is 0 minus h. Okay, what I did, understood? Just to show that I'm coming from left hand side, 0 minus h I have written. Clear? Now you put your function. Limit h tending to 0, fx is what? 0 minus h, when means, that means from left hand side, what is our function? Our function is x plus 1. When not equals to 0 means is x plus 1. So x, what is our x? X is 0 minus h plus 1, right? So here no problem, you put your limit, because it is not in the form of 0 by 0. You put your limit directly, so you get 1, left hand limit. Okay, so your left hand limit is 1 and this is 1. So therefore left hand limit is equals to 1. Okay, so this is the second point. Now let's go to right hand limit. Right hand limit, how do we write? Limit x tending to 0 plus f of x. 0 plus means what? 0 plus means coming from right hand side. That means it should be greater than 0. That means I will do let x equals to 0 plus h. So 0 plus h means greater than 0, little greater than 0. H is very small. So as x goes to 0, this becomes 0. Then what will happen? Check here. This will go on this side. It will be 0 minus 0. So h will also be 0. Okay. From here only solving we will get h. Okay. So now limit h tending to 0 f of what should I write? 0 plus h, because I have changed my x, okay, to 0 plus h. Okay, so limit changing should be done with the variable. Whatever variable you are writing, limit should be on that variable. Now check what is our fx at x on this side. There is also x plus h, x plus 1. So I will write that limit h tending to 0. So this is 0 plus h plus 1. Here, so you put, because this is not in the form of 0 by 0, so you can directly substitute your h, that is 1. So this is right hand limit is 3. So from 1, 2 and 3, left hand limit, which is 1, equals to f of 0, which is also 1, and this is the right hand limit. Okay, so you can write, therefore fx is continuous at x equals to 0. Okay, so that's it. That is your example. So this is what we have in continuity. Next topic will be differentiability, and in differentiability we will see what is the relation between continuity and differentiability. Thank you.